So now in this video, we have the 74HC32 integrated circuit right there. They're susceptible to static shock, so I'm going to make sure and disturb myself. But in case, there's 4 OR gates. It's a quad OR gate integrated circuit. We're only using one. The ones we're not using, we tied their inputs to the positive supply just to lock their outputs into place to avoid causing oscillation problems. But in case, we need at least one high input to get a high output. Now there's no hysteresis with this integrated circuit, as you can see. We can get both LEDs to light up, something to be aware of. But there we go. We got a high input from the trim pot and therefore a high output. Set it back low. We can also move this jumper to the positive supply for a high input. Now it's picking up straight signals. They're bouncing back and forth, but a high input equals a high output. Pretty straightforward. And of course we can also set the trim pot high. The output's going to stay high. As long as you got at least one high input, the output's going to be high. You can set them all high and so on. So now here's my schematic diagram for my 74HC32 OR gate. There's 4 on the integrated circuit because it's a quad integrated circuit, but we'll zoom in. And for demonstration purposes, I used a jumper that can go from positive to negative. If it's floating though, then you get stray signals and it keeps alternating. It's something to be aware of. And trim pot, we can go down to the low enough voltage or high enough voltage. There's no hysteresis for this though. There's a middle ground region where the output's kind of iffy. But in case, you have to get both of them to a low enough voltage to have a low output blue LED lights up. If one or the other gets a high enough voltage, or both of them, then you get a high output, the red LED lights up. Pretty straightforward. So the ones we're not using, we want to tie their inputs to either the positive or negative supply. But the one we're using, you just wire up. And so you got positive supply, negative supply for the integrated circuit. And there's the truth table. Any high input will lead to a high output. Both low in this case, the output will be low.